Let's read some end behavior and behavior near vertical asymptotes of three different functions here. First, y equals f of x. Reading this first statement, as x approaches -2 from the left, what does f of x do? Well, approaching -2 from the left means that we're going to read the graph as we come from large negative numbers all the way up to -2. Well, the function is shooting down to -infinity. As x approaches -2 from the right, f of x, what is it doing? Well, as I ride along this curve from numbers greater than -2, as I get close to -2, I'm shooting up to positive infinity. Now let's read the end behavior. So the end behavior, as x approaches positive infinity, in other words, as we get to very, very, very large values in x, we're reading all the way to the end of this picture here, and beyond, what is f of x doing? Well, remember, we're looking at the green curve, so let me erase what I've put before so we can see the curve a little bit better. Well, we can see f of x is approaching 0 from above. So it's actually approaching the x-axis, which is f of x equals 0, right? So now let's look at the left end behavior here. As x approaches -infinity, what is f of x doing? So, well, let's see. As I go farther and farther and farther and farther out, I'm getting very, very close to that horizontal asymptote of y equals 0 from below, so I'm also approaching 0. Now let's look at y equals g of x. So we have a vertical asymptote at x equals 1. As x approaches -1 from, or excuse me, +1 from the left, that's what the superscript of this minus sign up there means, from the left. That means we're approaching from numbers below +1. Well, I'm shooting off to -infinity. As x approaches 1 from the right, that superscript of a plus sign is read from the right. What is g of x doing? Well, from the right, as I get closer and closer to 1, I'm shooting up to positive infinity. Now let's look at both end behavior. Both going to positive infinity and to -infinity. G of x is approaching that horizontal asymptote of 1. Both end behaviors are 1, and it appears that we are not crossing that horizontal asymptote either. And finally, h of x. This is an example that has an oblique asymptote whose equation is y equals x, and we are going to describe the behavior near the vertical asymptote, which you can't see the dotted line on top of the line for the y-axis, but we have it here, so we know there's a vertical asymptote here. So as x approaches 0 from the left, what is y doing? It's kind of the pink or the purple graph there. Or excuse me, what is h of x doing? It's shooting to -infinity. And as x approaches 0 from the right, means I'm going along this curve and reading it while I'm shooting up to positive infinity. The y values are getting very, very large. And then the end behavior, you would just say that the function, as x goes to positive and -infinity, approaches the line y equals x. So in calculus, we would describe the end behavior of a function using limit notation. So, for example, if f of x approaches 0 as x approaches infinity, then we would write this in limit notation like this. The limit as x goes to infinity of f of x equals 0.